Okay, so this video is going to be on performing calculations in scientific notation. So we've just learned how to put a number in scientific notation by moving my decimal either to the right or the left, and then using an exponent. Now we're going to talk about calculations. And first, we're going to look about adding and subtracting in scientific notation. All right, so a review: scientific notation expresses a number in the form of this m would be any number between 1 and 10 times 10 to the nth power. N is an integer. It's what we call exponent. So an example, if I had the number 250 and I wanted to put it in scientific notation, then my decimal would be at the end. I need to get to a number between 1 and 10, and 250 is not that. If I move one place to the left, it's 25. That's not between 1 and 10. I need to go one more, and 2.5 is between 1 and 10. So that would become 2.5, or 2.50 if you want to include the 0, times 10 to the, and that would be, since I moved two places to the left, if I move to the left, that's positive places, so that would be 10 to the second power. If I had a number like this, with a decimal, to put my number in scientific notation, I need to move to the right of my decimal 1, 2, 3, 4 places till I get to 4.2. That's between 1 and 10, and that would be 4.2 times 10. And since I moved to the right, that's negative places, and I moved 4 places, so that would be times 10 to the negative 4. Now, if the exponent, when we're adding and subtracting, if the exponents are the same, we simply add or subtract the numbers in front and bring the exponents down unchanged. So we need our exponents to be the same number. In this case, they're the same to the 6th power, both of them. So we simply add our numbers, the 4 and the 3. 4 plus 3 is 7. And then that would be times 10. And our exponents, when we add and subtract, stay the same. All right, so you might want to write that down somewhere. When we add or subtract, the exponents stay the same. We don't add those or subtract them. So that'd be 7 times 10 to the 6th power. All right, now I do these, the calculator that I'm using, I can't use parentheses, but if you have a calculator that's got parentheses on them, you can punch it into your calculator, but you have to be very, very careful. You would want to do it like this. You want to put parentheses and then 4 times 10. And a lot of times on your calculator, if you have like a TI-30 or above, it will have a little sign like that right there, little upside down V, which means raised to. So you can punch that at 10 raised to the 6th power, close parentheses, and then you add, and then you have to put parentheses again for the next number in scientific notation, which will be 3 times 10 to the 6th. If you punch that in just like that, it will give you the correct answer, and you don't have to worry about figuring out your exponents. I'd encourage you to learn how to use your calculators. And also remember the little 10 raised to the 6th. You have to use parentheses though. If you don't use parentheses, it will do your order of operations wrong. If you didn't put any parentheses in there, it might give you the right answer, but a lot of times when you start dividing in scientific notation, it will give you the wrong exponent. So you have to make sure you use parentheses if you're going to use a calculator to do these problems. But you don't have to use a calculator. You can do it the way that I'm going to show you right now. All right, so if we look at some other examples, if I have let's say 7.3 times 10 to the 3rd plus 1.1. I would encourage you to write these problems down, these extra ones. 1.1 times 10 to the 3rd. Then I'm going to add the 7.3, and and the 1.1. That would give me 8.4. So my answer would be 8.4. And then my exponents are both 3. They stay the same. 8.4 times 10 to the third power. That would be my answer. If we look at one where we subtract, if I had 9.2 times 10 to the negative fourth minus 3.1 times 10 to the negative fourth. Now I'm going to subtract these two numbers. So that would be 9.2 minus 3.1. That would give you 6.1. So it would be 6.1 times 10 to the, our exponents are both negative 4. Since they're both negative 4, our exponent's going to stay the same. So that would be times 10 to the negative fourth. And like I said, if you can use your calculator, you wouldn't have to worry about these exponents, but just make sure that you put these numbers in parentheses when you put them into your calculator. And make sure it's just giving you the right answer to these problems. So you can work them both ways, by hand and with your calculator, to check it. That's all there is to adding and subtracting. You either, you add your numbers, the exponents stay the same, or you subtract your two numbers and the exponents stay the same. Now we do have kind of an exception though. If the exponents are not the same, we must move a decimal to make them the same. So if we have a number like this right here, 4 plus times 10 to the 6 plus 3 times 10 to the 5th, our exponents are not the same. We have to change one of these to make the exponents match up. Always pick the smaller number of the two, and that way when you move your, you can move your decimal to the left one place, and it will make the exponents match up. For example, if I was going to change one of these, I'm going to change the 3 times 10 to the 5th. I want to make that 10 to the 5th be a 10 to the 6th. Well, how can I do that? Well, I have my number here, 3 times 10 to the 5th. My decimal would be right there, my imaginary decimal. If I move it one place to the left, I get 0.3, and that makes my exponent times 10 to the 6th. Now they match up. Now I can add these numbers. So I can take 4 plus 0.3, which is going to be 4.3, and then my exponents is going to stay the same, times 10 raised to the 6th power, and that would be my answer. So I always pick the one that's the lesser exponent, move my decimal to the left, and make that exponent match up with the other one. And that's what this is telling you here. Determine which of the numbers has the smaller exponent. Change this number by moving the decimal place to the left and raising the exponent until the exponents of both numbers agree. Notice that this takes the lesser number out of the standard form, so it's no longer in that between 1 and 10, but that's fine. Then add or subtract the coefficients as needed to get the new coefficient. The exponents will be the exponent that both numbers share. Put the number in standard form. And you know what that means is sometimes when you do this, you might get an answer like 12 times 10 to the second or something. That's not in standard scientific notation form because 12 is not between 1 and 2. To change that into scientific, into correct scientific notation, I would put my decimal here, it's at the end of the 12, move it over one place, it becomes 1.2. Since I moved to the left one place, that becomes 1.2 times 10. I went over one place, that's a positive place, so it'll be 2 plus 1. So that would give me an exponent of times 10 to the third. So we always need to put our answers back into the standard form if when we add or subtract or multiply or divide, it takes it out of our standard form of scientific notation. Alright, so this is just going over what I just went over, what you need to do to change these numbers. Like I said, we moved this 1 over, and that became 0.3 times 10 to the 6, and then we were able to add them together to get our answer. And that's just, continuing on with the problem we just worked. So make sure your final answer is in scientific notation. If it's not, convert it to scientific notation, correct scientific notation, that is. So here's a problem. We'll work through this one together. Now, if you notice, our exponents are different, but they're negative. And I told you, always pick the smaller of the two and match it up with the other one. Well, if these numbers were positive, 4 would be the smaller number, so I would change this one. But since they're negative, actually this number, top number, is the smaller of the two. So to change that into correct scientific notation, if I move my decimal over 2 places, 2 positive places, that -6 will become a -4 because moving it over 2 places to the left, that's +2 plus -6 equals -4. So what that does, it becomes 0.0237 times 10 to the -4th. That's the number that I changed by moving it out of correct scientific notation. And then I leave the other number the same, 3.48. And that would be times 10 to the -4th. Now I'm ready to add these together. So when I add those, that would be 3.5037 times 10 to the -4th would be my correct answer. So when adding and subtracting, your exponents are the same, you just leave it alone and write it. If they are different, you have to change one of them to match up exponents with the other before you add or subtract. Now let's look at multiplying and dividing scientific notation. When multiplying in scientific notation, you multiply the numbers and you add the coefficients. So this is how it's different than adding and subtracting. When dividing in scientific notation, you divide the numbers and subtract the coefficients. So let's look at some examples. Let's say if I have 3 times 10 to the 4th, and I'm multiplying that by 2 times 10 to the 3rd. Now I'm going to multiply the 3 and the 2. 3 times 2 would equal 6, and 6 times 10. My exponents, the 4 and the 3, I'm going to add. Since I'm multiplying, I'm going to add those. So 4 plus 3 is equal to 7. That would be my correct answer. Now if we look at another one, if I had 8.42 times 10 to the -4th, and I'm going to multiply that by 2.1 times 10 to the -7th. So what I'm going to do first is I'm going to multiply the 8.42 and the 2.1. So if I have 8.42 times 2.1, I get 17.682. So my answer is 17.682, and that's going to be times 10, and that would be -4 plus -7. I add those since I'm multiplying would equal -11. However, I have a problem. And my problem is I'm not in correct scientific notation. I need 17.682 is not between 1 and 10. I need to put this in correct scientific notation. And I can do this by moving this decimal 1 place to the left. I move it 1 positive place and it becomes, my correct answer would be 1.7682. And since I moved it to the left, that's 1 positive place, that's 1, Then I'd add that to the negative 11. Positive 1 plus negative 11 equals negative 10. That would be my correct answer. All right, so if we look at another example, let's look where we divide. If I have 9 times 10 to the 8th divided by 3 times 10 to the 4th. Now I'm going to take the 9 and the 3 and I'm going to divide. 9 divided by 3 is equal to 3. And then my exponents, since I'm dividing in this case, I'm going to subtract the 8 and the 4. 8 minus 4 is 4. And that would be my correct answer. Now if we look at one more, if I have, let's say, 6.2 times 10 to the, say, negative 8, and divide that by 4.2 times 10 to the negative 2nd. So I'm going to take the 6.2 and divide it by the 4.2. And I get 1.476, and I'm going to cut that off at 1.476. And then that's going to be times 10, and I'm going to take the negative 8 and negative 2 and subtract those. So in that case, if I took negative 8 and subtract negative 2 from that, remember those two things, we got two negatives, you end up adding, or becomes positive. So negative 8 plus negative 2 would be negative 6, so that would be my exponent. (1.476) times 10 to the negative 6. Now, just to review, whenever we add and subtract, exponents stay the same. All right? When we multiply, we add exponents. And then when you divide, you subtract exponents. And if we're going to use a calculator, if you have a calculator that's got parentheses in it, what I would recommend if you had a problem, if you were going to take 4 times 10 to the negative 8 and divided by 3 times 10 to the 4th, you want to make sure that you punch in your calculator like this, parentheses, 4 times 10, then that upside down V on there, and then raise to the negative 8, close parentheses, divided by parentheses, 3 times 10 raised to the 4th. If you punch that into your calculator, it will get it just like that. Use your parentheses, it will give you the correct answer every time, and you won't have to rely on working this out by hand and subtracting your exponents in your head or whatever. So that's how I would suggest you do it if you have a calculator that has parentheses on there. And you can help each other figure out each other's calculators because some calculators are different how parentheses are used. So right now, what I want you to do is work these problems out at the end. These are here, you're going to multiply those numbers, then you're going to divide those numbers, and then you're going to use the PowerPoint to check your answers on these. And then I have a couple worksheets for you to do that combines everything that we've learned, adding and subtracting numbers, and multiplying and dividing. So just be careful what you're doing. When you add and subtract, your exponents stay the same. They don't change. You might have to change one number to make the exponents match up before you do the calculation. And then multiplying, you add exponents. Dividing, you subtract exponents.